Good afternoon to all. For today's session, in this session we are going to discuss about the engineering materials. What we have studied in the mechanics of solids for aerospace subject. So here our students are being available. They are going to discuss about the mechanical properties of the engineering materials. What are the properties are being used, and their examples we are going to discuss, as well as the stress strain diagram. The importance of the stress strain diagram we are going to explain. What are the stages from the material being loaded, and what causes so many stages like elastic limit, proportional limit, yield limit and all. Finally it attains the fracture. Okay. So in between number of stages it goes through. So they will interact one by one. We will see what the experience from our students.
Hello everyone, today I am going to talk about strength. Strength is one of the most important mechanical property of a material, as it defines its ability to resist deformation and a failure under applied load. In simple terms, it tells us how much force a material can handle before it breaks or permanently changes shape. Strength can be measured in different ways depending on the type of stress applied. Tensile strength measures a resistance to be pulled apart. Compressive strength measures resistance to be squashed, or shear strength measures resistance to be sliding force.
Hello everyone, I am Ductility. Now I am going to explain the mechanical properties called fatigue. Fatigue is one which will happen to a material when a material expresses a cyclic load or a repeated load. Because of this repeated load, the material will breaks down even if the force applied is lesser than the strength of the material. How it happens? It will happen when there is a scratch or there is a bending in a material. There will be caused a fatigue. For example, in aircraft industry, the aft flight wings bending up and down are caused due to fatigue. In simple way, fatigue is the one when a force is repeatedly applied in a material, it will got damaged.
Hello everyone, I am Arian from Aerospace Department. Today I am going to tell you about the elasticity of the material. So if you take about the elasticity of the material, first we just take a spring. So what will happen if we pull a spring and raise it? It will change its original position and it's deformed over some medium, and again it will come to its original position. That is what we call elasticity. So in brief, we want to define elasticity. We want to look into Hooke's law. So what Hooke's law says is stress is directly proportional to strain. So what is stress? Stress is nothing but force by area, and strain is nothing but change in position to the original position, the ratio of it. So it says that the strain and stress are directly proportional, and we get a proportionality constant that is called Young's modulus. So this is what we define as elasticity of the property. So it defines how much material can be stressed out and stressed in. So that's all.
Hello everyone, I am Avi from Aerospace Department. Today I am going to talk about the property of the material creep. Creep is the slow permanent deformation of a material when it is exposed to constant stress or over a long period of time, especially at high temperature. Unlike sudden failure, creep happens gradually. For example, in jet engines or rocket nozzles, metals face high heat and constant loads. So over time, they slowly degrade and stretch or bend, even if the stress is below their breaking point. Creep is usually divided into three types: primary creep, secondary creep, and tertiary creep. Thank you.
I am Rakshana from Aerospace Department. Here I am going to talk about the properties of material. So coming to the properties of material, here I am going to talk about thermal conductivity. So thermal conductivity is nothing but when a material is there, the temperature changes and the heat transfer takes place. That is said to be a thermal conductivity. Here they have many properties depend on that. Example, a specific heat capacity and diffusivity and moreover like that. So which deals with the material shape, size and also the change in the characteristics of low temperature to high temperature. And coming to the melting point of the thermal conductivity, it transfers from solid to liquid phase. It can help in the material size and shape. In this way it helps in material changes. And the applications are like heat sinks and aerospace industry and automotive things. And that's it. Thank you.
It was a very nice experience from our students, what they have interacted with themselves by our mentees about the mechanical properties of the engineering materials like stress strain. From the Hooke's law, they are introducing about the stress strain diagram also, why it is very important. Moreover, the strength, toughness, hardness, the example as well as malleability property, why it is very much important. And they have studied just now. They have shared their knowledges. Very impressive. We will see in the next class with a different topic. Thank you all.